Okay, so now we got another question where we need to solve for the differentiator, okay, of the operational amplifier. Okay, so it's gonna be just the same principle that we used before. So we need to find the transfer function. Okay, so you are asked to find transfer function. Okay, so the transfer function of this AC, it's gonna be V output over V in. Okay, let me just put it in S domain. Okay, in order for you to get the transfer function, now there are things that you need to pay attention. If you look here, we are working with the inverter pins, so this means we're going to have a negative sign here instead of a positive sign, because ground is connected to positive and the negative one is the one that we're using. So it's gonna get Z2 over Z1, and where Z2, this is where we have this is where you see we have Z2, and this is where you have Z1. So this one is Z1 and this one is Z2. Okay, we're going to proceed the same way that we did with the other question, the previous question. So we know V out over V in equal to, I'm going just to rewrite the equation, inductor impedance equal to, then you put negative there, you move one outside, so it's gonna be Z2 times 1 over Z1. Okay, so in this way we'll be able to place the value correctly, so then everything is really well placed. Okay, so then I'm going to rewrite this equation for the transfer function. It will be equal to what you see right here. So let's now replace the value of Z. Okay, if you have Z2, what is Z2? You can see Z2, if I have just to show you, this is where we have Z2, and since we have R, so we're going to use this equation. Okay, and for Z1, since we have C, we're going to use this equation there. Okay, so how I'm going to write this equation, so it's gonna be something like this. So let's start with Z2. Okay, so it's gonna be something like this. So for Z2, I'm gonna get, I need to take this what you see here, so it's gonna be IS times R. Okay, this is Z2. Now Z1, it's 1 over Z1. So let me just write it correctly. So what I'm gonna have here is gonna be C. So where's C? This is what we have. We can see for C. So it's gonna be 1 over CS times IS. Okay, and if I have to write this equation correctly, you can see these two will cancel out, or maybe let me just keep it the way it is, so you can see how we're going to cancel them out. So we have our negative here, we move 1 over S IS, and then we're gonna have S times R. Yeah, so let me just make it short. Then you will see that this one will cancel out with this one, So our equation is gonna be negative R 1 over CS. Okay, and in mathematics we know when we have a fraction over another fraction, it's gonna give us the answer will be minus CSR. Okay, but I'm going to prove to you how we got this. So we have something like this: negative R over 1 CS. So what you should know is we have how many fraction? We have this one, and we have this one. So we have one fraction divided by another fraction. Okay, so the way that I'm gonna write this equation, it's gonna be something like this: negative, it's gonna be R over 1. Any number in mathematics, we assume we have a denominator of 1. This is what we have. So a fraction over another fraction, it's gonna be the first fraction times the inverse of the second fraction. These are the rules for the fractions. It's gonna be CS, then we're gonna have 1 there. So we're going to flip this equation here. So we're going to flip it. So we're going to flip it, okay, to reverse it. Let me just put a nice sign so that we can see we have reversed that equation. And then later on, it will give us something like this: negative RCS. That's what you get for your, that's what we get for our transfer function. So I can even say, just to write it correctly here, V in S is equal to negative RCS for our transfer function. Okay, once you get that transfer function, you can later on solve for V out. So V out is gonna be something like this. So if I have to solve for V out in this equation, I'm gonna get something like this. So initially we got this equation equal to negative RCS. So V out, it should be equal to negative RCS times Vs, because in math you can move this fraction at the top of the second fraction, and we can assume that we have a denominator of 1 here. So we can move the denominator of that fraction times the other the numerator of the second fraction. So this is how, and the answer for V out is gonna be V out in S domain is gonna be negative RCS V in. So this is how you're going to get your final answer for V out, and then you can just do the inverse Laplace, and then you're gonna get it in times domain. Okay, if I take the inverse Laplace of if I apply the inverse Laplace here, the answer I'm gonna get, let me just make some room here so that I can show you. Okay, let me make some more. Okay, here at least we got enough space to, so then I can show you everything. So what you do here, you take the inverse Laplace. Okay, so when you do that, you will get you have your Laplace transform. So you can have Laplace transform and another Laplace transform of the other side. So you have something like this. So it's going to be VO is equal to negative RC S VI of S. So this will give you VO of t times domain negative so, and there's this thing, you're gonna take negative out, so you're only gonna take the inverse Laplace of the term in S domain. So you're only gonna take the inverse Laplace of S and Vs, so which is gonna give you something like this: negative S d, we know the integral of S. No, we know the how to represent the Laplace transform of S. If you check the Laplace table, this is what we get. We will get on our final answer. What you see here for V out in times domain. So this is in time domain. Okay, this is what you see here. So if you want to learn more about what we just did with Laplace transform, so Laplace transform of S, it will give you S, it's gonna give you dt, okay, and Laplace transform of S square, this is just to give you what to give you an idea. So if it's S square, you will get and so on. So this is just what we just did here. And if you have to see the whole resolution, this is how I went about solving this question. Okay, so you just get a transfer function and then replace the S domain into the equation, and then you can solve for the transfer function and maybe V out at the end.